Hello everyone, I am Amit Maru and today in this video we will discuss about Floyd Warshall algorithm. It is algorithm to find the shortest path. It is also known as all pair shortest path algorithm. The topic of dynamic programming and the concept of analysis and design of algorithm subject. So let us start our today's video on all pair shortest path algorithm, that is Floyd's Warshall algorithm. We already discussed the shortest path algorithm in a greedy approach. It was a Dijista's algorithm. It was a single source shortest path algorithm in that we have to consider one node as a source node and remaining node as a destination node. In this algorithm, we cannot find a shortest path for all pair, and this is the limitation of Dijista's algorithm. So that we have to use another algorithm, that is a Floyd Warshall algorithm, in that we can find a shortest path for all pair of the node. So let us start a Floyd Warshall algorithm. Suppose we have one graph in that number of node, capital N number of node and capital N number of edges are there. These all the edges are non-negative edges, in that the length of every edges is non-negative, and we want to calculate the length of the shortest path between each pair of the node. As per the dynamic programming concept, we have to construct one matrix, that is capital D matrix, that gives the length of the shortest path between each pair of the node. There are certain steps that we need to follow to find the solution, to find the shortest path for all pair of the node. Step number 1, the algorithm initialize L to D, that is the direct distance between node. So the first step of Floyd Warshall algorithm is we have to identify direct distance between all the nodes, and we have to store inside one matrix. This matrix is known as capital L matrix. This L matrix we have to initialize into capital D matrix. It means that initially we have to identify direct length from one node to another node, and we have to store inside the matrix, and this matrix is known as capital D matrix. Step number 2, it then does an iteration. After iteration k, D gives the length of the shortest path that only use nodes in 1 to k as the intermediate node. This is the basic concept of Floyd Warshall algorithm, in that we have to consider every node as the intermediate node to identify the shortest path from one node to another node. The third step is after n iteration, the D therefore gives the length of the shortest path using any of the node in capital N as the intermediate node, which is the result we want. Right? So after n iteration we will have one capital D matrix, in that we can have a shortest path from one node to another node, or we can say the shortest path for every pair of node is available in our capital D after n iteration. Let's take one example. Suppose we have one graph in that 4 different nodes are there, node number 1 to node number 4, and we want to find the shortest path for all pair of the node by using Floyd algorithm. As per the Floyd algorithm, the first step is we have to prepare 2 different types of matrices. The matrix number 1, that is a direct distance between nodes. We have to prepare one matrix capital D, in that we have to store a direct distance between node. So the size of the matrix depends on the number of nodes. For example, here 4 different nodes are there, then we have to prepare one matrix initially, in that 4 number of rows and 4 number of columns will be there. And we have to store direct distance between all the node. So we have to consider row as a source node and column as a destination node. So for example 1 to 1, 1 to 2, 1 to 3, 1 to 4, that we have to store all the values in our first row. Then after 2 to 1, 2 to 2, 2 to 3, 2 to 4, that we have to store in our row number 2. In this way we have to fill this matrix, but here we have to store direct distance from one node to another node. So let us store all the values, all the direct distance from one node to another node in our capital D matrix. So first step is, we have, as we discussed, we have to consider row as a source and column as a destination node. So 1 to 1, so is there any path from 1 to 1? So it is a 1 to 1, that is a self node. So 1 to 1, there is a distance 1 to 1, that is 0. Then 1 to 2, so there is a direct path from 1 to 2, yes, and the distance is 5, so we have to store 5 here. 1 to 3, that is the first row, third column. Is there any direct distance from 1 to 3? There is no direct distance from 1 to 3, so we have to put sentinel symbol. One thing you have to note it down here, if there is a direct path from one node to another node, at that time we have to put this value. Otherwise, if there is no direct path from one node to another node, at that time we have to put positive sentinel symbol, and this positive sentinel symbol we are considering as the highest positive value. Then 1 to 4, that is first row, fourth column. So is there any direct path from 1 to 4? No, there is no direct path from 1 to 4. So again we have to put sentinel symbol. Then second row, now we have to consider 2 as a source node and column as a destination node. So 2 to 1. So second row, first column, 2 to 1. Is there any direct path? Yes, 2 to 1, there is one direct path and the length is 50. 2 to 2, so it is a self node, so we have to put 0 there. Then 2 to 3, is there any direct path from 2 to 3? Yes, and the distance is 15. 2 to 4, direct path is there and the distance is 5. Then we have to consider third node as a source node. So 3 to 1, is there any direct path from 3 to 1? Yes, and the length is 30. Then 3 to 2, there is no any direct path from 3 to 2, so that we have to put sentinel symbol. 3 to 3, that is self node, so that we have to put 0 there. 3 to 4, yes, there is a direct path from 3 to 4 and the distance is 15, so that we have to put 15 here. Then last row, or we can say the last node, so we have to identify direct path from fourth node to the other every node of the graph. So 4 to 1, is there any direct path from 4 to 1? Yes, and distance is 15. Then 4 to 2, there is no direct path from 4 to 2, so that we have to put sentinel symbol. 4 to 3, there is one direct path, 4 to 3, and distance is 5. And 4 to 4 is 0. So in this way we have to fill our capital D matrix initially, and that we have to store direct distance between all the nodes. Now second step is, we have to prepare another matrix, and this matrix is basically used to identify the shortest path, and it is basically used to identify the intermediate node. Again, the size of this matrix will be again 4 by 4, 4 number of rows and 4 number of columns, because we have a 4 number of nodes. Now in this matrix we have to fill intermediate node value, but initially we have to put same value as a row value. For example, the first row has a value 1, so that we have to put 1 1 1 in our first row. Now in second row we have to put 2 2 2, because it is a second row. Same way we have to put 3 in a third row and 4 in a fourth row. This is the initial step, in that we have to store value as per the row value. If the first row, then we have to put 1. If second row, then 2. Third row, then 3. And fourth row, then 4. Actually, this all the value is intermediate node, and initial value is the same as row value. So this is the two matrix, and we will use these two matrix to identify the shortest path and shortest distance for all pair of the matrix. So now for this graph we have initially two matrix, matrix D, which has a direct distance of one node to another node, and matrix Q, which has a intermediate node value. Now as per the basic logic of our Floyd algorithm, we have to take intermediate node to reach to the destination node, and we may get shortest path. Just take one example. Suppose if you want to reach from 2 to 1, then the direct distance is 50. There may be a chance that if we use intermediate another node and if we reach from 2 to 1, then it is less than the 50. Just take one example. Suppose if we use a 3 as an intermediate node and if we reach from 2 to 3 and 3 to 1, then the total distance is 15 plus 30 is equal to 45, which is less than the 50. Now we can also check another intermediate node. For example, if we use 4 as an intermediate node, then 2 to 4 and 4 to 1, so the total distance is 5 plus 15 is equal to 20. So the direct distance says that it is a 50, but if we use 4 as an intermediate node, at that time it will be 20. If we use 3 as an intermediate node, then it will be 45. So in this way we have to check all the possibility and we have to identify which one is minimum. And it is a basic concept of Floyd algorithm. So as per the Floyd algorithm, we have to consider every node as an intermediate node, and then we have to identify shortest path which is minimum from all the possible intermediate node. So let us start. Let us consider every node as an intermediate node. So we will consider 1 as an intermediate node, 2 as an intermediate node, 3 as an intermediate node, and 4 as an intermediate node. And we will get different values of capital D and capital Q. At the end, we will have a shortest path in capital D, and we will have a intermediate node value in our capital Q. Now let us consider 1 as an intermediate node, and let us find the different values of our capital D. So now the value of k is equal to 1. It means that if we consider node number 1 as an intermediate node, and let us find different values of capital D matrix. So now when we consider 1 as a intermediate node, and for the first row our 1 is nothing but our source node. So by default it is a intermediate node. So we can have a same value as our initial value of our capital D matrix. So when we reach from 1 to 1, so answer is definitely 0. When we reach from 1 to 2, at that time we are considering 1 as an intermediate node, and when we reach from 1 to 2, then answer is again 5. There is no direct path from 1 to 3, so the sentinel symbol, and there is no direct path from 1 to 4, so again it is a sentinel symbol. So when we consider as a 1 as an intermediate node, at that time for the first row it is definitely same as our initial value. Now let us fill our second row. In that 2 is our source node, and remaining node like 1, 4 and 3 is a destination node, and that we have to consider intermediate node also. So for example, if you want to reach from 2 to 1, so here a second row and first column, that is 2 to 1, at that time we have a direct path, that is distance is 50. And 1 we are considering as an intermediate node, so there is no change. 2 to 1, only one path is available, so the answer is 2 to 1 is equal to 50, and 50 we have to store here. Then 2 to 2, this is the self node, so that definitely your answer will be 0, but we have to consider 1 as an intermediate node. So 2 to 1 and 1 to 5, another path is also available. So if we consider 2 to 2 direct path, then it is 0, but if we consider 1 as an intermediate node, then 2 to 1 and 1 to 2 path is also available, and the length is 55. Among these two, which one is minimum? Definitely 0, so we have to put 0 there. Then when we reach from 2 to 3, at that time direct distance is available, that is 15. So is it possible to use intermediate node 1 to reach from 2 to 1 and 1 to 3? No, there is no other path, so we can directly consider our direct path, that is 15. That is 2 to 3 is equal to 15 is our answer, so that we have to put 15 here. Then 2 to 4, so 2 to 4 direct distance is 5. And is there any other path in that we can use 1 as an intermediate node, or we can say is it possible to reach from 2 to 1 and 1 to 4? No, it is not possible, so that we have to consider 2 to 5 as an intermediate, 2 to 5 as a answer, and we have to fill inside the matrix. So we have to fill 5 here. Then fill our third row, and we have to consider 3 as a source node. Now reach from 3 to 1. So is there any direct path 3 to 1? Yes, there is a one path 3 to 1, and the answer, or we can say the distance, is 30. Now we are considering 1 as an intermediate node, so that 3 to 1 is equal to 30 answer, and we have to fill 30 here. Now 3 to 2, so 3 to 2, there is no direct path, so that the value is a sentinel value. So when we use a intermediate node to reach from 3 to 2, at that time can we get a path? Yes, so 3 to 1 is 30, and 1 to 2 is equal to 5, so we can get 35 as a direct path. So when we reach from 3 to 2, then it is a sentinel symbol, but through intermediate node 1 we can reach from 3 to 2. At that time the distance is 35. So which one is minimum? 35. So in place of sentinel symbol we have to put 35 here. So in place of sentinel symbol we have to replace 35. Then 3 to 3, definitely it is a 0. Then 3 to 4, when we reach from 3 to 4, there is a direct distance, that is 15, and we also have to consider intermediate node 1. So 3 to 1 is equal to 30, and 1 to 4 there is no direct path, so we have to put a direct length, that is 3 to 4 is equal to 15 as an answer. Now let us fill our last row. In that 4 is our source node, and 1 we will consider as an intermediate node. So if you want to reach from 4 to 1, then 4 to 1 has a direct path, and the answer is 15. And when we use 1 as an intermediate node, at that time definitely again we can get 15. So the answer is 15. Then we have to store 15 in our matrix. Now 4 to 2, when we reach from 4 to 2, at that time there is no direct path. So when we see here 4 to 2, at that time our sentinel symbol, it means that there is no direct path. If we use 1 as an intermediate node, then 4 to 1 and 1 to 2. So 4 to 1 is equal to 15, and 1 to 2 is equal to 5. So 15 plus 5 is equal to 20. When we compare 20 with the sentinel symbol, then 20 is minimum, so that we have to fill 20 here. So we can get another value in place of sentinel symbol, that is 20. Now 4 to 3, there is a direct distance 5, and we can consider 1 as an intermediate node, but we cannot reach from 1 to 3 because there is no direct path from 1 to 3, so that we can say the direct distance from 4 to 3 is 5, and it is a minimum distance, so that we have to put 5 there. Now last 4 to 4, definitely it is 0. So in this way we have to fill different values inside our capital D matrix when we consider 1 as an intermediate node. Now our next step is we have to update our Q matrix. So we have to identify a new value of our Q matrix, and it is depends on the value of capital D matrix. So we have to just compare our D matrix with our previous value of D matrix. This is the D matrix when we consider one node, or we can say node number 1 as an intermediate node, and this is the initial value of capital D matrix. We have to just check there, is there any difference between these two matrices? If yes, then we have to note down the difference. For example, in our first row there is no difference. In our first row there is 0, 5, sentinel. But when we consider 1 as an intermediate node, at that time again first row has no change, 0, 5, sentinel symbol. And in our second row 50, 0, 15 and 5, here again 50, 0, 15 and 5, there is no change. But in third row there is a changes. In a third row second column the value is 35 when we consider 1 as an intermediate node, and before that it was sentinel symbol. And in fourth row second column again it is a 20 when we consider 1 as an intermediate node, and before that it was sentinel symbol. So in this both these cases there is a change when we consider 1 as an intermediate node. Third row and second column, and fourth row and second column. so that we have to change the value in our Q matrix, and we have to fill value of K, because K is equal to 1 is nothing, but we are considering 1 as an intermediate node. So we have to put 1 here and 1 here. It means that third row second column is equal to 1 and fourth row second column is equal to 1, and this 1 indicates our internal intermediate node. So remaining values are as it is, and we have to change this both the value. Third row second column is equal to 1 and fourth row second column is equal to 1, and this 1 indicates our intermediate node, and the value of intermediate node is equal to 1, so that we have fill 1 here. So in this way we can update our Q matrix, and it is depends on the value of capital D matrix. Now this is the value of capital D matrix and capital Q matrix when we consider node number 1 as an internal node. Same way we have to consider node number 2, 3 and 4 as an internal node, and we have to change the value of capital D and capital Q. So let us consider our node number 2 as an internal node. So now the value of K is equal to 2. It means our node number 2 is our intermediate node. Now let us change the value of capital D. Fill the capital D matrix. Let us fill our first row when we consider node number 2 as an internal intermediate node. So now 1 to 1, so self node 1 to 1 is equal to 0, but when we consider 2 as an intermediate node, at that time 1 to 2 is equal to 5 and 2 to 1 is equal to 50. So 50 plus 5 is equal to 55. Among this 55 and 0, 0 is minimum, so that we have to fill 0 here. Now to reach from 1 to 2, we have direct path 1 to 2, and our answer is 5, and 2 is our intermediate node, so that direct path is 1 to 2 is the answer, and we have to fill 5 here. Then to reach from 1 to 3, we have no direct path from 1 to 3 because it is a sentinel symbol, so there is no direct path from 1 to 3. But when we consider 2 as an intermediate node, at that time 1 to 2 is equal to 5 and 2 to 3 is equal to 15, so we have a 20 length from 1 to 3 when we consider 2 as an intermediate node. So among these two values, sentinel and 20, 20 is minimum, so that we have to fill 20 here. To reach from 1 to 4, we have no direct path and the value is sentinel symbol. But when we consider 2 as an intermediate node, at that time 1 to 2 is equal to 5 and 2 to 4 is equal to 5, so total is 10. So 1 is sentinel, that is 1 to 4 sentinel, and 1 to 2 and 2 to 4. When we consider 2 as an internal node, at that time it is 10, so the minimum value is 10 and we have to fill 10 here. When we compare this both the matrix, at that time in our first row, third column, here sentinel symbol, but now here it is 20. Here 1 to 4, that is sentinel symbol, but now here we can get 10 when we consider 2 as an intermediate node. Now let us fill our second row. Here we are considering 2 as an internal node, and we are going to consider 2 as a source node, so there will not be any change in our second row. All the value will be as it is. So 2 to 1 is equal to 50, 2 to 1 is equal to 50, as it is value we have to fill here. Then after 2 to from node number 2 to node number 2 is equal to 0 because self node. Then 2 to 3, there is a direct path from 2 to 3 and 2 is an intermediate node, so the answer is 15. And 2 to 4, and then the answer of 2 to 4 is equal to 5, and intermediate node is also 2, so that answer is 5. Now let us fill our third row. So the first value is 3 to 1, so the direct path 3 to 1 is equal to 30. And when we consider 2 as an intermediate node, at that time 3 to 2 and 2 to 1, 3 to 2 is equal to 35 and 2 to 1 is equal to 50, so 50 plus 35 is equal to 85. Among this both the value, the minimum value is 30, so that we have to put 30 here. Then 3 to 2, 2 is our intermediate node, so 3 to 2 is equal to 35, so 35 we have to put as a answer, and we have to fill 35 in our matrix. Then 3 to 3, so it is a self node, is equal to 0. Then 3 to 4, then we have to fill 3 to 4. Here 3 to 4 is equal to 15. So the direct path is 15, but when we consider 2 as an intermediate node, at that time 3 to 2 and 2 to 4, 3 to 2 is equal to 35 and 2 to 4 is equal to 5. So 35 plus 5 is equal to 40. Among these two values, 15 and 40, the 15 is minimum, so that we have to fill 15 here. Now let us fill our last row. So we are considering 4 as a source node. So let us reach from 4 to 1. When we reach from 4 to 1, at that time direct path is 15. But when we use the intermediate node 2, then 4 to 2 and 2 to 1. 4 to 2 is equal to 20, and 2 to 1 is equal to 50. So 50 plus 20 is equal to 70. Among these two values, 15 and 70, the 15 is minimum, so that we have to fill 15 in matrix. Now 4 to 2, when we reach from 4 to 2 and our 2 is intermediate node, so that the 4 to 2 is equal to 20. So the 20 is answer, and we have to fill 20 inside the matrix. Then reach from 4 to 3. At that time direct path from 4 to 3 is equal to 5. And when we use intermediate node 2, at that time 4 to 2 and 2 to 3. So 4 to 2 is equal to 20 and 2 to 3 is equal to 15. So 20 plus 15 is equal to 35. Among these both the value 5 is minimum, so that we have to fill 5 here. And last 4 to 4 is equal to 0. So in this way we have to fill our D matrix. We have to update our D matrix when our node number 2 is an intermediate node. So again we have to change the value of capital Q matrix. We have to update our capital Q matrix based on the matrix D. As we discussed, we have to compare our previous D matrix with our current D matrix, and we have to check the values. In our first row there is a 2 change. First row, third column, here sentinel symbol, and now here it is a 20. In previous D matrix, the first row fourth column has a sentinel symbol, but when the intermediate node is 2, at that time it is our 10. So here first row third column is equal to 20, and here first row fourth column is equal to 10. And remaining all values are as it is. There is no change in remaining all the values. So according to this rows and column, we have to update the value in our capital Q matrix, and we have to fill value of k is equal to 2, because 2 we are considering as an intermediate node. So we have to fill 2 here, and we have to fill 2 here. Here first row third column is equal to 2, and first row fourth column is equal to 2, and remaining all the values are as it is. This is the updated Q matrix. In that we have filled intermediate node value. Now same process you have to do when we consider our node number 3 as an intermediate node, and our last node, that is node number 4, as an intermediate node. So when we consider node number 3 as an intermediate node, at that time we can get updated capital D matrix and updated capital Q matrix. You have to follow same process, and we can get this kind of 2 different matrix, capital D and capital Q. Now we have a last node, that is a fourth node, and we have to consider node number 4 as an intermediate node. Same process again we have to follow, and we have to identify updated value of capital D matrix and capital Q matrix. This is the last matrix, and this is our answer. So our capital D is basically used to identify shortest distance, and capital Q basically used to identify intermediate node. So let us use this last both the matrix to identify shortest path and shortest distance. So let us discuss how we can find the shortest distance and shortest path by using this final matrix, capital D and capital Q. So this is our graph, and this is our final D matrix, and this is our final Q matrix. Now suppose if you want to find shortest path and shortest distance from node number 1 to 3. If you want to reach from 1 to 3, then find out the shortest distance and shortest path. So as we discussed, D will give shortest distance and Q will give shortest path. So first identify the shortest distance from this D matrix. Then 1 2 3, that is first row third column. First row third column is equal to 15. It indicates that the shortest distance from 1 to 3 will be 15. But from this matrix we cannot identify the exact path to reach from 1 to 3, so that the distance will be 15. And for that we have to use capital Q matrix. As per the capital Q matrix, if you want to reach from 1 to 3, at that time we have to check first row third column, and the answer is 4. It indicates that if you want to reach from 1 to 3, at that time we have to use 4 as an intermediate node. So use 4 as an intermediate node. But there is no direct path from 1 to 4, so that we have to check first row fourth column. First row fourth column is equal to 2. It indicates that if you want to reach from 1 to 4, then we have to use 2 as an intermediate node. Now again we can check from 1 to 2. So first row second column is equal to 1. So 1 itself is an intermediate node. So that this is the path to reach from 1 to 3. So the shortest distance is equal to 15. At that time we have to follow this path 1 to 2. So we have to reach 1 to 2 first, then 2 to 4, and 4 to 3. Then we can have a shortest path is equal to 15. So in this way we can find the shortest path for all pair of the node by using Floyd's algorithm. So let us discuss now pseudocode of the Floyd's algorithm. As per the Floyd's algorithm, the first step is we have to identify L matrix. L matrix is nothing but the matrix for the direct distance. So fill one matrix, that is capital L. In that we have to fill a direct distance from one node to another node, and this matrix we have to store inside the another matrix, that is capital D. Then after we have a 3 different loop. One loop for outer loop, that is k is equal to 1 to n. This loop basically for the intermediate node. When the value of k is equal to 1, it means that we are considering node number 1 as an intermediate node. Then after node number 2 as an intermediate node, and last, that is nth node, we are considering as a intermediate node. Inside this loop we have another 2 loop, that is I is equal to 1 to n and j is equal to 1 to n. It is basically used to fill the matrix. I indicates row and j indicates column, and this both the loop nesting of loop basically used to fill the matrix. Inside the matrix we are filling the value which is minimum value. So this equation basically used to identify the minimum value. In that we are comparing direct distance, and one value in that we are using our intermediate node. So which one is minimum, that we need to identify, and we have to fill inside the matrix. So this inner both the loop basically used to identify the minimum value, and basically used to fill the matrix. At the end we have to return the capital D matrix. It is nothing but our answer. So this is all about Floyd's algorithm. So thank you very much for watching this video.